Hello everybody, I hope this video and all the videos find you well, safe, and healthy and in good spirits today. It's a very rainy day here in Western Massachusetts today, but still, well, I'm happy to be talking to you all about not only tissues and cell junctions, but also cancer as a sociopathic cell. So in this video, we'll be talking primarily about components of the extracellular matrix, and we'll be focusing on GAGs, or glycosaminoglycans, as well as collagen-integrin interactions and how cells in general adhere to the collagen of the ECM. So first, GAGs. GAGs are for compressive forces. So if you have ever, and even if you haven't, and yes, that's my horrible hand, if you haven't, know that if you press on a part of your arm, you put a compressive force there, you'll actually see a discoloration. You'll see that the part where you pressed will become a lighter shade of your normal complexion, and then within a few seconds it will fill again and look normal. What you're doing when you press down on your skin is you're excluding water. You're pushing water out of that region, and rather than doing damage to the underlying tissue, instead the water release is essentially absorbing the force of that compression. You can think of this as a sponge. So imagine that you have a very, very delicate, thin glass table. That represents the tissue, and it's very susceptible to damage. If you wanted to give some compressive protection to that thin glass table, you could put a wet sponge on top of it. Now imagine you press down firmly on the sponge. What's going to happen? Well, you're going to push all of the water out of that sponge. And none of that compressive force that you're applying is actually going to reach the glass table. And so the glass table will remain unharmed. As you release that compressive force from the sponge, all of the water that was released is going to be reabsorbed. The sponge will be rehydrated once again and ready for the next compressive force. In this example, that sponge are these GAGs. They are the glycosaminoglycans. So GAGs are they contain these highly articulated sugars. Articulated just meaning very, very branched, complex carbohydrates. And these articulated sugars that are included by the GAG molecules, they absorb water. These are polar sugars, and water interacts very favorably with them. In fact, water becomes bound to these complex carbohydrates in a non-covalent way. This is your molecular sponge, and it is now full of water. If this is the underlying tissue here that's susceptible to damage, and this is the epithelial here, as a compressive force is applied down onto this skin, essentially, or in the knee, this also happens in many, many joints that are more prone to compressive forces. As we apply that, we compress the sugars, and we squeeze out the water. So here's that compressive force, and the sugars distort. They are compressed as well, and all of the water that was taking up that volume is moved off to the side. This causes that discoloration as you press on your skin. But what we see is that the underlying tissue is completely unimpacted by this compression. It's not even being deformed by the compression. Then, as that compressive force is released, and we allow those sugars to go back to their original conformation, we not only see the tissue spring back to its original shape, but we see that it regains its color because all of this water is rehydrating these GAGs. And again, the compressive force never made it to the tissue at all. So I use the analogy of an airbag in the actual lecture for GAGs, but this idea of thinking of it as a sponge encompasses a little bit more of what the GAGs are doing, because as you squish the sponge, the water is released. You don't harm that thin glass table under the sponge, and as you release the pressure, the water is reabsorbed. Another thing that came up in the Edpuzzle questions from the ECM was this idea of collagen and integrin interaction. So we have a lot of fibrous collagen in the ECM, the extracellular matrix, and we know that the cell is expressing integrins. We've talked about that in previous weeks. The integrin is a transmembrane protein, and integrins are interacting with the actin of the cell cortex. So that's how we get our anchoring. But the new player here is that we actually have fibronectin, a new protein, that is bound to the collagen of the ECM, and the fibronectin is what interacts with integrin in order to allow cells to adhere to or crawl along the ECM. So integrin is not making direct contacts with collagen. Instead, integrin is interacting with fibronectin, and fibronectin is interacting with collagen. So let's draw that out in words. To get a cell to adhere to the ECM, it is actually an actin to integrin to fibronectin to collagen interaction. So there are 4 protein players here in this cell adhesive force. Actin is directly bound to integrins, integrins directly interact with fibronectin, fibronectin is bound to collagen, and that's what anchors your cell. A lot of you ask, well, why? Why do this? Why have this way? Why can't integrins just interact with collagen? So now what we're going to do is we're going to draw an ECM from the aerial view, so to speak. So now we're looking down on the ECM, and we have cells that are adhered to and or crawling on the ECM. Let's take a moment to appreciate the role of fibronectin in this. So here is fibronectin as these brown dots. And as I draw this, you'll see that fibronectin is not evenly distributed across the ECM. Some regions of the ECM lack fibronectin, and other regions of the ECM contain fibronectin. In this way, the cell can control, the organism can control where cells can adhere to and where they can't. For example, this region here and this region of the ECM and this large region here, these are cell exclusion zones. Because these regions lack fibronectin, cells cannot adhere to nor can they crawl along these portions of the ECM. But this region here is almost a fibronectin path, and this cell can continue to crawl along in this direction or crawl backwards on this fibronectin path and make its way to some new organismal target. So fibronectin allows there to be zones that can be inhabited and adhered by cells, and it also creates these fibronectin paths that control the directions that cells can crawl in. If cells could crawl and adhere to collagen directly, then the entirety of the ECM would be fair game for cells to stick to and crawl on, and that's not necessarily what the cell wants. So that wraps up some of the more confusing aspects of the GAGs and the collagen integrin story with fibronectin as an intermediate.